If you've ever been to a talk where you watched it later at 2x speed, this is not going to be that one because I'm going to be speaking 2x speed to get through all these slides. So, at Cruise, we are building the most advanced autonomous vehicles and running the backend on Kubernetes. We have self-driving cars in San Francisco right now, and there's a couple hundred of them navigating the streets autonomously, and pretty soon we'll have some of those available for you in a ride-hailing service. But here I'm not going to talk about the cars too much, mostly talking about the backend, which runs on Kubernetes. So this is just an example of how our cars talk to Kubernetes in the backend. There's a couple different ways, either over the internet or over our private fiber backbone through some physical routers online in our data centers or in our garages, and then over interconnects for high-speed transfer data. Because it turns out you can't send enough data over LTE or even 5G when you're recording with so many different devices on the cars. So a little bit about Cruise's paths. We have a constellation of different components that make up our paths. So that includes bits about ingress and egress, security, observability, deployments, and management infrastructure. A lot of these are open source tools or SaaS products that we integrate with, and a bunch of them we wrote ourselves. Some of them are not yet open source or still private. I'm going to glance over a bunch of them in slides in a few minutes, rather than talk about them all right now. So we have a little bit of scale. There's a little bit of irony in at scale here, but we generally have our largest multi-tenant clusters are around 1,000 nodes. This is sort of reaching capacity where real workloads start to struggle on Kubernetes. And there are larger synthetic tests that show you can get to like 3,000 or 5,000 nodes. But generally what we find is that when you get above 1,000, a bunch of different things start to break down. So this is where we are, and most of our load in production runs on one of these big clusters, this blue line. These are pod count graph, and it's showing we have a high dynamicism with pods that get scheduled and deleted pretty frequently, along with more consistent workloads. We have a very wide variety of workloads, including services and jobs, and agents that process jobs, and databases, and semi-stateful storage, a whole bunch of things. So we like to use multi-tenancy because it gets us a little more higher utilization on our nodes, among other things. So a little bit about multi-tenancy first, because it's poorly understood or communicated in different ways by different people. When I talk about multi-tenancy, I talk about multiple applications operating in a shared environment. And usually, when you have multiple applications, you also have multiple operators. So there's a little bit of contention over whether the applications are the tenants or the operators are the tenants, but it doesn't really matter because you're gonna have more of these anyway. And chances are, everybody who's running Kubernetes is running a lot of different applications on them, not just one application. So you can call the application the tenant, you can call a system of applications a tenant. It's really up to you how you define this. But the crux of multi-tenancy is the logical isolation. In order to get from logical isolation, or rather to build logical isolation, you have to put in a whole bunch of components on top of Kubernetes. Kubernetes has some of this isolation built in, and some of it you bring yourself. If you go all the way to physical isolation, then you're not really in multi-tenancy anymore. If you have full physical isolation, that's really just single tenancy or multi-instance. So the more physical integration you have, the harder it is to preserve logical isolation, and the more expensive it is the less expensive it is. So if everything is running on the same hardware, it's cheaper to run until it breaks. And then if everything is separate, then it's more expensive to run, and you've sort of reached the edges of multi-tenancy. So why multi-tenancy? Obviously, cloud cost is one of them. I won't go too deep into that one because it's a little obvious. Lower operational cost is another one. If you're starting up a platform team with like 5 people, you might not be able to operate 5 clusters realistically, much less 30 to 100 clusters. So having fewer clusters means fewer people needed to manage it, but you have to invest in being able to do multi-tenant securely with good operations and security practices. High scale validation is sort of unique to us, is that we wanted to get to a higher scale and see what the limits were before we got customers on our platform. So we do say we're running in production right now because we have cars on the street that talk to our backend, but it's not necessarily full production because we don't have customers in those cars yet. So we still have a little bit of time to fix up everything before that happens. And we wanted to make sure that we tested the edges before we got there. In terms of higher consistency, this is just the standard idea that a rising tide lifts all boats. We wanted to make our investments in a focused area so that it applied to as many of our internal tenants as possible to get them to production readiness specifically. So I talk about multi-tenancy in layers. These are not necessarily checkboxes where you're like, oh, I did this, I'm done, I never have to touch this again. It's more like areas of concern in isolation. So starting at the bottom, these ones are kind of the things everybody needs in their multi-tenant stack, and at the top, you're getting to the point where not very many people have these because they're harder to do, they're more expensive to do, and I'll go through each one of these in a minute. I would really like to be on a beach right now. That's part of my identity. But in Kubernetes terms, what we're really talking about is authentication. So we have user identity and service identity. So these are kind of the bread and butter, the table stakes of authentication. So I won't go too deep into them, but in our case, we're using G Suite because we use GKE, it's baked in. And we use Okta for single sign-on and Duo for two-factor auth. For service identity, Kubernetes service accounts you're probably familiar with. GCP service accounts is because we're on that platform and they integrate together with GKE specifically. Then for logging into service accounts, usually use a signed certificate or a JWT with some sort of refresh token, and that refresh token allows you to log in until it expires, so you have some sort of time window for how long they can log in. These are just basic security principles. My coworker, Mike Ruth, talked yesterday at one of the Day Zero conferences about this, so you can pull up his talk to go deeper. One of the tools the infrastructure team worked on is Daytona, which is a sidecar application. This is one of our early open source projects, and it allows you to bind your secrets to your application containers with a in-memory volume, so it never gets written to disk, so you're not leaking your secrets. And it gets these from Vault using logging in with the Kubernetes service account. And then you can do this thing called identity translation. That's my word, not necessarily an industry term yet, but the idea is I can get from Kubernetes service account to GCP service account to AWS service account to wherever kind of service accounts you're using without having to inject them all at configuration time. It allows for a little bit looser configuration, and it pulls us in at init time or deploy time. You can also pull them in at runtime if you want to, and if you have tight integration with Vault, you can do that, but it requires a little more investment, so we do it at deploy time for the most part. K-Rail is another tool that we built specifically to allow for policy validation. So with the existing tools in the marketplace, we found it difficult to validate on existing clusters, figure out who was violating those policies, apply exemptions, and then roll out to an enforcement policy, and then backfill the people who were in exemptions to get them to stop doing those crazy things. And some of those crazy things are like, mounting the Docker socket, which is completely insecure, or using bind mounts to places that are on the operating system that you don't want them to have access to, or acting as host PID. I won't go through all of these, but one of the things we noticed when we did this was that the default Docker seccomp profile gets disabled by Kubernetes because of some reverse compatibility concerns. So we go and enable that with a default at a mutating webhook. So the webhook applies these things when the pods are created, and then they automatically get these security features for free. That's also an open source tool, and it's available on GitHub. So next layer of isolation is domain isolation. There's a lot of different ways to slice this. So when I talk about domain isolation, I'm talking about environmental, organizational, and architectural domains. So Kubernetes, you basically have two options for slicing these orthogonal. You have clusters and you have namespaces. The SIG for multi-tenancy is working on hierarchical namespaces, but they're not there yet. So what you have now is a choice. You got to pick two of these. So this island has Fitbit on one and logs on the other, just so you're aware. The way we've sliced this is originally environmental versus organizational. So we have clusters for our environments in different VPCs, and then we have namespaces for the teams. So we thought this worked great for a while until we realized that in hypergrowth, your teams change really frequently. And then you have to refactor all your namespaces all the time. So what we switched to instead was a project-based namespace, which allows for more granularity, for tighter security, and still gets you the benefit of an orthogonal domain. We started with one cluster in each environment, and we've moved to multi-cluster as we've needed, but I'll talk about that a little later. So permission isolation is the next layer of multi-tenancy, and this really comes down to authorization and authorization management. Kubernetes gives you the tools to do RBAC, but it doesn't really give you the tools to manage your permissions above that. So oftentimes you need some other layer on top of that to make that work. One of the tools that we wrote to help this out was RBAC sync, and RBAC sync allows us to bind groups, Google groups specifically, to role bindings, use role bindings on groups to give them roles, to give them permissions, because the roles are a set of permissions. And then one other feature we threw into this was the ability to add service accounts to groups, so we could do the same thing for service accounts. There is a new feature you can sort of see also at the bottom that GKE has added an integration recently with Google Groups, but they still don't have service accounts in groups yet. So if you want that, we still provide it here. This is also an open source project. Vault workspaces. So in terms of managing your secrets, right now with Kubernetes, you're effectively managing them at the namespace level, which if you're at a team level might not be as secure as you want. If you're at a project level, it might be fine. It kind of depends. We wanted more security than that and more isolation, so we isolate our secrets at the application level or at the workload level. So one of the ways we do that is with a standard hierarchical path in Vault, and then that allows us to have an application space in Vault, and then your application has its own service account, and then it can log in and grab those secrets for your application, but nobody else's. So in terms of managing these, we have to do some GitOps of Vault permissions, and that's not quite as easy as it could be, but it effectively allows us to subdivide these even more than Kubernetes default allows. And then at the higher level, because you're at the namespace boundaries, you can give your teams permissions to read or write those secrets based on your needs. You might just only need like lists to be able to see that they exist, but you might also need your on-call to be able to update them in runtime, or you might have CI go through and push these out live. Isopod is a tool that we wrote specifically for add-on management, and one of those add-ons was managing permissions for a while. So this is similar to Helm in the idea that it's used for deploying things, but instead of templates, we write code in Skylark, which is a Python subset. So Skylark allows us to have a nearly Turing-complete language in order to programmatically make templates for our add-ons, because we didn't really want to go through the hassle of releasing every single add-on when we're running 20 per cluster and have to deploy them to 20 clusters. So this allows us just to push out master to the top of our set and deploy it everywhere all at once, which may not be your requirements because you might have more diversity than that, but it works for us. Also, less YAML makes people happy sometimes. And the Helm Tiller alternative was insecure at the time. Thankfully, Helm 3 is out now. And the Terraform Kubernetes plugin at the time we started this wasn't really usable. I've heard they've invested in it a little more. We need to check on it again. But this is a fun tool, and it's also open source. Next thing we wrote was Juno. Unfortunately for you guys, this is not open source, but it is an internal project for now. And this allows us to configure a lot of different things for our tenants to increase their isolation and improve our operational speed. So for example, here we see we can enable GCP projects. I can add them to a shared VPC. I can create a Vault workspace, and I can create a Kubernetes namespace. So we hope to allow this to self-service, to create namespaces on demand for our users. And ideally, you can either authorize people to do that by using groups, or you can do a sort of request approval process where the platform team approves these resources granted, because each of these resources comes with an effective quota, and you need to do some capacity planning around it, which is still yet to be isolated. So resource isolation is sort of the next tier here, and there's some built-in types, the CPU, GPU, memory, everybody kind of knows those when they use Kubernetes. The ones that are sort of less isolated is persistent storage and ephemeral storage. Let me step back on the persistent storage for a second. You can isolate that really well because it's one disk to one application. unless you're using local persistent storage, and then it gets a little more complicated. You have to pre-mount your applications, or have some way to pre-mount your drives, or have some runtime drive mounting. It's pretty complicated to manage, and the storage classes are, the quota is all storage class specific. So if you have like 2 storage classes because they're in 2 different zones, but your quota is regional at the project level, then you have to like add those together to get your quota. It makes capacity planning a little harder. Ephemeral storage is the real bugger here though, because there's quota and usage, but you only get usage if you have the quota applied, and there's no pod level usage yet. So you can't really enforce the quota because people come to you and they're like, how much am I using? What should I set my requests and limits to? And you're like, I have no idea. So we're working with Google and Datadog to help improve the ephemeral storage mapping up here. But another thing you have to concern yourself with ephemeral storage here is that all of these storage volumes here in the middle all share your root drive unless you've subdivided them some more. So you might want to consider isolating those so that your Docker images don't take up all your space on your storage volumes, or your storage volumes don't block you from being able to launch more pods, or your OS crashes because one of your pods is using too much disk. We had a fun bug where we crashed Docker because we were using too much disk, and then Docker slowed down, and the health check for Docker waited 30 seconds and then killed it, and then waited for it to come back up. But if you were using too much disk, it would never come back up. So you ended up with a cascade failure where you'd get evicted from the node and crash the entire cluster. So don't do that. We're still waiting for quality of service here. Another step here for quotas and limits. You can put quotas and limits with the default resources, but if you want to manage defaults those on the namespace, there's no current tool for that. So we do this with Juno or Isopod, and allows us to set a default quota for each namespace when we create the namespace. And then we set a really low limit for resource limits on CPU and memory to force people to specify. That creates a feedback mechanism that requires them to know about resources or have some tool that does that for them. Next level is network isolation. I wish our data centers looked like this. They're really cool. Got a nice air gap there. We don't have that. Instead, we have shared tunnels. So shared tunnels here, one to call out is NAT gateways. NAT gateways like to fall over, especially if you're using them with static IPs. Static IPs then get whitelisted by people who are doing things that maybe they shouldn't do. Then you have whitelists strewn across everybody, and you can't auto-scale your NATs because then you'd have to go update all the whitelists or things break. So don't do that either. Whitelists are bad. But we switched from a built-in, a self-deployed Terraform module managed NAT gateway that didn't scale very well to CloudNat when that was offered by Google, and so that's worked a little bit better for us, but it still has the same whitelist problem. Ingress egress QPS is completely unisolated, so unless you are running something like Istio, you basically don't get QPS or request isolation between containers or pods on the same node. So what we did was we went from Broadwell to Skylake and got twice as much network speed to avoid the problem. But hopefully we're working towards increasing QPS isolation or just ingress egress. Worth noting, if you're using network storage, that is shared on the network, like it's in the name. So your network and your storage are now unisolated from each other, much less the pods they're on. So there's a little bit of complexity there that needs to be separated, and you might want to use like actual physically attached disks instead of network attached disks if you need more isolation. Bandwidth here, there's a CNI bandwidth plugin, but it doesn't work on GKE because the version of Calico isn't new enough. So we've asked them to increase that, and we'll try that out pretty soon. In the meantime, we're working on Istio, where we can get rate limits with the layer 7 load balancer. Worth calling out that layer 7 load balancing is slower than layer 4, almost universally. So if you inject this in, you've got to make sure that you qualify it and make sure it's not going to break your applications. So speaking of Istio, network policies built into Kubernetes are great, except for when they're not, which is when you're managing them, because managing IP blocks is effectively managing whitelists. It's no fun. Namespace selecting and pod selectors tends to be a blunt instrument, and it's not really great unless you have very fine-grained namespaces where your namespaces are your application, and then you want to control them between. We like the Istio model a little bit better, although it's kind of complicated, but you can effectively do denier or list checker, that's basically blacklists and whitelists. You can also do service authentication, which allows you to say, this service account has access to access this service run by this other service account, and then make policies that enforce what can talk to what. Integration isolation. This one is the biggest unsolved problems, I think. When you have Kubernetes, Kubernetes is not enough. And you need a whole bunch of other things. Like I said, a constellation of components and applications and operators, all sorts of stuff. We mix in a bunch of SaaS products too, you might not. But each one of those probably isn't as isolated as Kubernetes is. So one of these examples is load balancing. We've been using the Nginx controller for a long time. We found that we didn't like it running on the same nodes as the application, so we moved it to its own node pool. And then we found that we didn't like isolating our own, managing a new node pool and having it have different rules than everybody else, and also then have 2 layers of autoscaling. So we moved it out to GCE. Now we have the load balancers running on VMs, and then we have 1 layer of autoscaling, and it's much more performant and just as easy to manage. There's some, so you can give, this is kind of a lesson in isolation. You can give it your own node pool, you can give it its own nodes, you can give it its own VMs, you can make them per tenant. Unfortunately, there's no current mechanism for spinning up or requesting a new actual physical load balancer for every namespace. So I know there's an investment in the API machinery SIG to work on gateways and gateway classes. So I'm hoping that pans out pretty soon so that we can say, I need a new one of these for this namespace or this tenant. Another problem here that we don't have very well isolated is DNS. This is just kind of a lulz slide in how DNS is set up, because you have a cache in front of 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 DNS. So this is just private zones, but basically your DNS on the cluster is really easy to overwhelm with any of your tenants, and that will affect every other tenant. And unfortunately, that's just the way it is. You can slice these by node pool sometimes, if you have some way to set up the DNS differently, like node labels on GCP, for example. But there's not a good way to isolate this per tenant, because there's no way to say this namespace only can use this node pool. We've been thinking about using a validating webhook to enforce that, but there's no way in Kubernetes to lock those two together right now. This one, I'm not going to dive too deep into, but shared observability is a big problem. All the logs, all the metrics, all the tracing tends to go to a SaaS provider, or if you're running your own, it all goes to the same place. So there's usually the SaaS providers will have multi-tenancy because you are a tenant, but they don't have 2 layers of multi-tenancy, so you can't give tenancy to your users underneath you, or that you're hosting for. So if you're running your own, also like Prometheus and Grafana have the same problems. They're not really designed for it. They might have authentication, low-level multi-tenancy, but they don't have authorization rules for most of this stuff. This is just a fun hack we made to get logs into a different project in GCP. So we actually double emit container logs so that they can get into a team project, and that team has access to do log-based metrics. That way they can self-service their metrics, and those metrics then go to Datadog, and then they can do the alert flow the way they normally would, rather than having to come through us and do some like GitOps management of the log-based metrics. Also, more critically, they can do dashboards in their project, whereas we don't want to give them edit to our project because then they'd stomp on each other's toes. That's like the opposite of isolation. So, as was mentioned, you can go from no isolation, sharing a cluster admin account, which I don't recommend, to logical isolation, which has been called sort of soft multi-tenancy before. Hard multi-tenancy is kind of the idea that you don't trust the people that are underneath you. I don't recommend that for a Kubernetes install because of all these sort of isolation constraints or problems or yet to be implemented features. And then system isolation is really single tenancy or multi-instance strategy. So you choose what layer you want to do, and what works for you may not work for everybody, so there's a lot of complexity in that, and it's hard to provide a single done and sold solution. You can isolate at the machine level, you can isolate at the node pool level, you can isolate at the cluster level, you can isolate at the network level. Any one of these would be real system isolation. The components, it's good to call out that each one of these components I listed, you can get to scale issues pretty quickly. So if you're running in a multi-tenant environment, you get more scale just by default, and then you might hit some of these boundaries, and then you have to back it off and give them separate clusters in order to isolate those components. So, was it worth it? Sure. The goal of this whole strategy was to save us money, lower operational cost, get scale validation, and rise the tide of all boats. So I think we did that. The biggest cost was shared downtime. So any one user's bugs or any one user's system like running into somebody else's bugs or running into an isolation boundary that doesn't exist, and they can take out everybody else. So that becomes a security issue if you get compromised, but it's also an availability issue just with your regular tenants. So generally it's good, but you have to make sure that your use cases are good for it. So what we've done is we started one big cluster. I mean, we have dev stage prod, but our prod one's the biggest, and we put everybody on that until it hurts, and then we move them out. So we have a couple other tenants with their own clusters, but I wouldn't call them single tenant clusters because it's really like a team. They get their cluster, and then that team has different projects. They get different namespaces. So we really have a bunch of multi-tenant clusters. They're just isolated on different boundaries. Another thing we learned here is that we got a bunch of security improvements prioritized because they were also operational and isolational concerns. And I think that's a win for everybody, is investing in these security tools, which might have been overlooked otherwise. And then expertise building. We have broken Kubernetes many times, and so that allows us to know where the edges are and what not to do in the future, or what to work around, what to prioritize in terms of fixes, and I think that was valuable, especially before we have customers that we would embarrass ourselves in front of. Another of the costs here is incompatible tooling. Turns out that not just integrations, but tooling tend to be incompatible. One of them I mentioned earlier was like Helm Tiller. It didn't have any Auth-Z in it, so it was really like you install a Helm and it can install the whole cluster, bypassing your tenancy rules, or you install it in a namespace and you run multiple instances. It's not very great. Helm 3 now has the option to basically use CRDs and RBAC, but you have to carefully configure that. So we haven't done that yet, but we're looking into it. Another one I'd call it is Kubeflow. It has its own sort of tenancy model, so it doesn't really match with ours, so we can't really install it with everybody else's namespaces, for example, because it creates and deletes namespaces. So it basically has to have an equivalent to cluster admin or more permissions than a tenant would have, so you can't put it in a tenancy box. So we give that as its own clusters too. CRD installations, another one. The platform team has to manage CRDs because they're outside of the namespace and they're shared by the whole cluster. It's a global resource. And this is a little bit unfortunate because we'd like people to self-service their own operators, but at the same time, it gives us an option to review the operators they're installing to make sure they're not going to do something that's going to break down all the other tenants. And so one of the things that this also gives us in general is not just the CRDs, but the chance to review tenants that we pull into the system and do some capacity planning with them and make sure that we have quota for them, make sure that they're not doing anything crazy like a lift and shift without understanding what cloud native means. But that's a time-intensive process. And so it also slows down the self-service aspect. So that's kind of a challenge, pro and con. And Kubernetes itself is hard, not just for the platform team, but for everyone using it. And so they all have to learn it. They all have to learn the PaaS tools that we integrate with. And we're constantly building new abstractions that they either have to learn in parallel or that hides some complexity from them. But there's no one system that overlays that makes this simple that is also multi-tenant, so we couldn't just pull one off the shelf. Alrighty. That was it. Got through that pretty quick.
So we have a few more minutes for questions. Any questions? Who was first?
Hi, Karl. Thanks for sharing this with us and very informative. So I'm Yuan Chen from JD.com. I have two questions. The first one is, can you talk a little bit more about your use cases workloads? The second one is in terms of resource isolation, and do you see the disk I/O and like the bandwidth and is a key challenge there? And that's a problem in our multi-tenancy and Kubernetes platform. Thanks.
So I guess two questions. One is on whether the bandwidth in QPS isolation is required or a problem, and the other one was based on our workload styles or types. So we have a lot of different workloads. We have standard web applications, microservices. We also have jobs that we get kicked off by an external scheduler. We have cron jobs that happen nightly for batch job stuff. We have sort of semi-stateless stuff like Elasticsearch or a cached layer. And we also, Redis databases, for example. We also have full stateful databases, only a couple of them. And then we have a bunch of agents that run jobs or launch pods and effectively act as like custom schedulers, except they're internal. So those are usually fed by a pub sub queue and then want to scale based on the depth of the queue. So we have all those systems together and a couple more stragglers that I didn't mention, but it's enough that we can get pretty good isolation. But we also have some jobs that like want to use 60 CPU. We have to give them their own namespace in order to isolate them a little more. Otherwise, they'll block scheduling or won't be able to schedule themselves. And then we have, in terms of the bandwidth and QPS, we sort of solved the immediate problem that we had by giving more bandwidth, but it's not isolation. So it's a security problem because you can DOS the system by taking down a node. You can take out the NATs gateways, and that's a security problem. But also it's an availability problem. So I think the disk isolation and network isolation that basically don't exist or have very rudimentary solutions are some of the biggest win areas to invest in Kubernetes isolation.
Hi. How can the multi-tenancy working group help you in terms of native features for Kubernetes, especially for security?
So there's a little bit of complexity with us running on GKE, which means that we're not running an upstream Kubernetes version, and GKE is a little behind on versions, and we're behind on their versions, and so if there's a new patch into Kubernetes, it'll take like a year to get to us. So that's something that needs to be improved both by upstream and Google, but if it's an external controller that we can apply, that's a much easier way to do it, and I think that extensibility with operators is the way to go. I have been interested in the hierarchical namespace operator, but it overlaps with a bunch of the stuff we're doing. So I'd also kind of like smaller tools that I can slap on to add to an existing set of tools rather than something that tries to do everything.
Hi. How you are managing the project level CI/CD pipelines in your cluster? Like, is there any segregation is there?
That's the slide I had to leave out for time. We have a couple different CI systems, and our primary CD system is Spinnaker right now. We wrote a Spinnaker operator internally to manage accounts, to have accounts per namespace per cluster, which means we have hundreds of accounts, and then we have to have a tool that manages that for us. So we have like a Spinnaker account CRD that you make resources for, and we have to pre-provision those with some GitOps, and then the Spinnaker account sets up through the operator to inject and restart Spinnaker running on Halyard inside the cluster. And then that alone is also another use case I didn't mention that spans a lot of resources running continuous deployment.
Okay, we are out of time, so if you have more questions, feel free to reach Karl.
All right, thanks for
privately.
coming.
Thank you very much.